This is an example of a hypothesis test for a dependent sample. Data was collected on the heights of parents and their adult children of the same gender. Each row of the data represents the heights of a parent and his or her adult child. Explain why this is a dependent sample, and then test the claim that the mean for children is greater than the mean for parents. You can assume that the conditions for doing a hypothesis test are met. So we'll look at the data in a moment, but what you're going to see is that in the first column, you have heights of students, and in the second column, you have the height of his or her parent. So for example, row 1 of the data, there's a student height and a parent height, and these two people are related. These two numbers, one is for the student and one is for his or her parent. Similarly for row 2, you're going to see the height of a student and then the height of his or her parent. So these two numbers are related to each other. They're paired. And that's what makes this a dependent sample. You might wonder, well, what would it look like if it was not a dependent sample? If it was not a dependent sample, in the setup of the problem, you would read something like this. We collected some student heights and we collected some parent heights, but these numbers in the student heights and these numbers in the parent heights, the numbers next to each other do not represent a family relationship. You just have a bunch of students, a bunch of parents in random order. But the data that we're going to see, let's take a look at it right now. For example, in row 1, there was a student that was 70 inches and his or her parent was only 65 inches tall. In row 2, we see a student who's 71 inches and his or her parent is also 71 inches. So the two numbers that are next to each other represent a family unit, a parent and a child, an adult child. Okay, so let's go ahead and take a look at how we would do this hypothesis test. So the first thing we're going to do is we're going to write our null and our alternative hypothesis. Now the symbol we use here is the mean of the differences. So this talks about the mean or the average of the differences. And so just as a reminder, when you do one of these problems, you're taking the number in the first column, the students, and we're going to subtract the number in the second column, the parents. And what we're interested in is what this difference is. So this stands for the average of the differences. So for example, there may be a student that's 70 inches tall and a parent that's 69 inches tall, and when you subtract those, you get a difference of 1. You may have a student that's 70 inches tall and the parent is also 70 inches tall. When you subtract them, you get a difference of 0. You might have a student that's 68 inches tall and a parent that's 70 inches tall, and when you subtract them, you get -2. So the numbers could be positive, they could be negative, or they could be 0. So if we're saying that we were wondering, are students taller than parents? That was the question we're trying to answer. So if students are taller than parents, then when we subtract them, we're starting with a larger number and subtracting a smaller number. And whenever we do that, we're going to get a positive difference. In other words, a number which is greater than 0. So our alternative hypothesis will be that the average of the differences is greater than 0. And our null hypothesis, of course, will always have an equal sign in it. The conditions we were told were satisfied in the problem. So we don't have to worry about checking anything. We were just told to assume that they were satisfied. Either you need a large samples that are greater than 25, or populations which are normally distributed. But in this problem, they said we didn't have to check. And so now we're going to find the test statistic, and this is about means, so it's going to be a t-statistic and a p-value. Now I'm going to show you how to do that in StatCrunch. But what you're going to do is you're going to go to Stat. You're going to go to t-stats because this is about means. And we have a dependent sample. And you're just going to make sure that in the alternative hypothesis, the sign matches what you want it to be. In StatCrunch, there's another style for writing these where they take both parameters and put them on one side of the inequality or the equation. But basically, you just have to make sure that the sign matches up. And then we'll come up with our conclusion. Now I'm going to go ahead and write the conclusion now because I've already found the test statistic and p-value, but then I'll go and show you how to do that yourself. So when you do this, your test statistic comes out to be 2.27, and your p-value is going to come out to be 0.01, which means it would be highly unusual to find this sample if the null hypothesis was true. And so we don't believe the null hypothesis is true. This p-value means that we're going to reject the null hypothesis. We believe the alternative is true, so that meaning that evidence suggests adult children are taller than parents. So let me show you how to find that in StatCrunch, just to confirm how to find the test statistic and p-value using this path. So you're going to come to Stat, T-Stats. We have a paired sample. Sample 1 we're going to use for students. Sample 2 we're going to use for parents. You may wonder, if you reverse them, would it make a difference? The only thing you would have to make sure you did if you reverse them is make sure you thought out what sign you want in your alternative hypothesis. But like we talked about before, for this problem, if we keep students in sample 1 and parents in sample 2, to show that parents are shorter than students, in other words, students are taller than parents, it would be the same as having a greater than sign in your alternative hypothesis, and then you just compute. And so we see our test statistic, 2.27, and our p-value, which led us to reject our null hypothesis.